quality of service, what we learned yesterday is providing knowledge to the router to differentiate the traffic in different types according to the type which it has been identified, the prioritization, the preference, the weightage, the care, additional care level is applied. Generally, routers do not have that knowledge of differentiating the traffic. For routers, all traffics are same. But when we configure quality of service, we are asking routers to see routing protocol as a type of traffic, voice as another type of traffic, FTP as another type of traffic, Telnet and SSH as another type of management traffic. So routers start seeing them as different traffic. So now, according to the classified and identified traffic, now we are able to assign some extra care, some policy, which will make the network utilization and service provided in a more efficient way. For example, if you are inviting all your friends around the globe, I have friends all over the continents, various continents and countries. If I'll invite everyone, first of all, I should know how many South Africans are there, how many Mid Africans are there, how many North Africans are there, how many Europeans and how many North Europeans and South Europeans. Because the food varies, you see. If I want to invite them and give them good food, I need to first take a study and classify and differentiate the people from different region, and I need to hire cook from all this region to cook for all these people, all these friends. Only then I can satisfy them. I cannot put sambar and rasam and vada to all. Definitely they won't like. No one will like. Maybe 5% of friends may like it. 95% of my friends don't want to eat it. That sambar and appalam and vadai and tair. So, though all are human beings, all my friends are of same race, human being race, men and women. I have to classify if I want to provide good dinner service. I have to differentiate, classify, and prepare food accordingly. Then, when I serve, they all get really satisfied, happy. Otherwise, whatever you give, the best Indian food, that won't make them happy. Maybe Indians are happy for that food, but definitely not my African friends. I've seen that. So, in order to provide a service, you have to take this much care, not just the money and the food that you give. It is what food and how much money where you spend matters. Likewise, when I see a voice traffic that needs that special attention, like no one stops, no delay, and between the source and destination, the time taken should not be more than 200 to 300 milliseconds delay. All this we have to take care, otherwise the voice traffic will get upset and go from the party. Voice traffic needs special care. Every traffic is different. Some are tiny and time sensitive. Again, voice is the example for that. Some are very big, like FTP, and not really time sensitive. It can be slowed down even if one or two packets get dropped of FTP traffic. It is okay, can be resent, recovered. That's not the case with voice. If any one voice packet get lost, finish. Cannot be resent again. Even if you resend, it won't be useful because it's streaming, it's live. So these things that which I spoke now, we went really deep yesterday. Now I have again spent another 10 minutes on that to just tell what is QoS. Now we are going to see here what is policing, shaping, weighted random early detection, and virtual output queuing, VOQ. We also learned yesterday that differentiated service is what we see in most other places, not in-serve. In-serve is reserving end-to-end, blocking the bandwidth just for one customer. Not really recommended because we will lose a lot of customers then. Differentiated service is hop by hop service. Every hop wants to treat, give weightage, but not the same weightage that other routers give because some routers are very high in performance, whereas some are not. So depending upon the capacity, the weightage need to vary. So we understood that differentiated service, diffserv, is what we do. In that, policing is one of the method to avoid congestion. Policing is one of the method to avoid congestion. What is policing? Policing is keeping an eye on the incoming traffic or the outgoing traffic and see whether those transactions, those sending and receiving is within the limit of the committed rate. If it is beyond the limit, those excess packets should be dropped. That is policing. Excess packet dropping. Policing will drop any bits that is coming beyond more than what is committed. Shaping is Before sending traffic to the service provider, the enterprises people, what they do is they check whether they are sending within the limit. Why? If they send more than the limit, policing is going to drop their packet on the service provider side. Yes, policing is done on the service provider side. Shaping is done on the customer side. It is done on the customer side. Shaping is done on the customer side. Customer, instead of getting dropped on the service provider side, what they do is they do policing. Sorry, they do shaping. Before sending it, customer want to check whether it is within the limit we are sending. If there is more traffic to send, they slow down so that it will go within the limit. Slowing down, that is shaping the traffic, controlling the flow so that it won't go beyond the committed. You see, these two are avoiding what? Congestion. Policing also avoids congestion. If everyone is sending excess, then there won't be enough resource for customers to move freely, customers' data to move freely. So it avoids congestion. When you set some limit, there is a control over congestion. When you don't have a limit for each customer, then you will not know who will grab the bandwidth, when he will grab the bandwidth more. What if everyone want to grab more excess bandwidth at the same time? There won't be enough resource and then congestion is going to occur. Shaping also does the same thing. To avoid congestion, it is sending within the limit so that it won't go more and form collision, congestion, traffic jam. Now, this is another method, weighted random early detection. What it is before congestion happens. Before congestion happens. That is what the word early here, E, early. Before congestion happens, that is what detected here, early detection. Before early detection. Before congestion happens, the routers are configured to drop packets. Yeah, literally routers will start dropping packets to avoid congestion. So, say for example, if you are a traffic police, you know that 8 o'clock is a peak hour. 8 o'clock, everyone wants to use the road. School going children, office going people, everyone. So what you do is, from 7 o'clock itself, you start dropping unwanted traffic in the road. How do you know it is unwanted? Because at 8 o'clock, a big lorry full of some goods is unwanted. So you identify that lorry and say, stop on the side of the road. So you make the lorry not to enter into the city, because if the big lorry goes in, it is going to cause traffic. So you start dropping some traffic from the road because you suspect some congestion at 8 o'clock. So you start dropping some traffic right from 7 o'clock so that when 8 o'clock comes, all this unwanted traffic won't be there on the road and you avoided congestion. See, you are very choosy in dropping. You are stopping only the lorries. Because lorry has got nothing to do at 8 o'clock. They need to be in the market around 10:30, 11 o'clock. Now, who is important in the road? The office going, school going, traffic. See, that is the weightage that you give for the school going, office going people. They got more weightage than the lorry. The traffic with low weightage is stopped, is dropped from the road so that the high weightage traffic will not experience congestion. So at 8 o'clock in the road, only the high weightage traffics are there, and for them, that bandwidth was more than enough. No congestion. But earlier, when you didn't do the dropping, when you don't stop the lorries, including lorry, everyone were held up in the traffic. Too much congestion. So this is weighted random early detection. We have already classified the traffic and we know which one is more important than other. We have set weights. We have marked it with CoS or ToS or DSCP values. We have already marked. The one with the high marking will not get dropped. For example, if you have CoS 5 traffic and CoS 4, CoS 3, CoS 2, CoS 1, 0, all traffics are there in the road. When the bandwidth is 70% used, immediately WRED, what it will do, it will see the packets with low weightage like CoS 0. It will start keeping an eye on CoS 0 traffic, which has got very less, no weightage. And now when the traffic goes beyond 70% of the bandwidth, it will start dropping the CoS 0 traffics. It will start dropping it. It won't allow it to pass through. It will start dropping CoS 0 packets. Now, there won't be congestion. Let's say even after dropping all CoS 0, the traffic is still going beyond 70%, hitting 75 now. As soon as it hits 75% of the bandwidth, it start dropping CoS 1 also. CoS 0 and CoS 1. But more of CoS 0 and less of CoS 1 is getting dropped now to make sure there is no congestion for CoS 2, 3, 4, and 5. If still congestion is increasing and that is going to hit 80% of the bandwidth, along with the CoS 0 and 1, now it starts dropping CoS 2 also. So that CoS 3, 4, 5 will never get dropped. This is what called as weighted random early detection. It is not dropping after hitting 100% bandwidth. It is not dropping after hitting 100% peak, right from 70%. This method of controlling the congestion is what called as weighted random early detection. This VOQ is not supported in all devices. It is supported only in Nexus device. For some, it is totally new. This is like single input, multiple output. I repeat, single input and multiple output. A traffic is entering on one port, but the destination is via multiple ports. Maybe it's a multicast traffic. Now, what will happen usually when there is single input and multiple output? Usually, what will happen if there is any problem here, congestion here, all will not forward. This also won't forward, this also won't forward because it's the single flow need to go via 1, 2, and 3. But the 3 port have got congestion. Port number 3 is experiencing some congestion. Because of that, port number 1 and 2 also will stop. Because of 3, port 1 and 2 will also stop forwarding the traffic. That is normal. That is the default behavior. But after VOQ, you create a separate virtual queue for this one, and this one. So when this virtual queue is impacted, these virtual queues will not. It will be keep on forwarding as usual. So we put them in a virtual queue. When it is a physical queue, problem. So you put it in a virtual queue. That's why it is V. You see, virtual output queue is a queuing mechanism that is designed to prevent head of line blocking in switching and in switches and routers. In the system with input queue and single physical queue at an input can hold a packet designated to multiple outputs. If one output is congested, just now I said that, if one output is congested, it may block packets designated to other outputs. So why we use VOQ? VOQ solves this by maintaining separate queues, which is virtual, per output port, so that if congestion happens in one output, it does not prevent packet destined to other output from being forwarded. This is something new in quality of service, and it is not there in every other device except Nexus. Okay, so that is about VOQ. Nexus 7000, we configure this. Now, whatever I have explained, I have also make as a document here nicely. And I have also given examples to configure them. This is what weighted random early detection. You see, random detect. And if the threshold goes to this level and maximum this level, after reaching this, it will stop. It will start dropping the traffic with less weightage. Now, so with all the configuration example for weighted random early detection, and this one is shaping, and then I also have an example for policing here. You see police. If traffic is within this limit, allowed, no problem. If little bit excess, up to 8,000, allowed. You can also say 8,000 to 8,500. But here they're saying only 8,000 in this example. Means this is the actual allowed. you are a little bit liberal. You want to give some excess. If within this limit you transmit, you are allowed to transmit. If that exceeds more than that, if the excess goes more than 8,000, you are going to drop. This is policing. Policing is done on the service provider side. Shaping is done on the customer side. Right, I have documented all this thing. Go through this and we will see the remaining stuff in our next class. Do you have any question on what I have covered today? Right.